This video will cover the basic setup of the Digital Lynx SX acquisition system with the computer. All images and descriptions reference the Digital Lynx 4SX, but are applicable to the 16SX as well. All Neuralynx equipment is electrostatic sensitive and should be handled with appropriate care. Always wear a static strap and use all suitable ESD measures when handling any electronics. The Digital Lynx SX system will arrive in one box, packaged in ESD-sensitive packing foam. It will be shipped with a 15-volt power supply, power cord, and 2 optical fibers. The computer and additional accessories, like head stages and tethers, will arrive in their own separate boxes. Carefully unpack all components of the Digital Lynx SX system. The Digital Lynx SX can either be rack-mounted or just set on a flat surface for recordings. Pay attention to the environment surrounding the system, avoiding nearby large electrical units and power supplies. With that being said, the Digital Lynx SX is reasonably compact and mobile, compared to other systems, and can be easily repositioned if the original placement produces too much noise or interference. The system is made up of 3 basic components: an aluminum cabinet that encloses a backplane, the Digital Lynx SX motherboard, and backplane modules such as input boards and DRS-36 or Digital Reference Selection 36 boards. The Digital Lynx SX will come fully assembled with the appropriate boards in place. If applicable, the Digital Lynx SX will arrive with an input board DRS module and/or a global reference module attached to the system. An input board DRS module is a newer version of the 80-pin ribbon cable, serving the same purpose of connecting the DRS board to the input board. This links the 2 boards, sending an analog signal from the DRS panel to the input panel, where it is converted to digital. If you have various DRS panels, a global reference module, previously a global reference cable, is inserted into the global reference MDR connectors on each DRS board to link them together. Plug the power supply cord into a power strip and into the power receptacle on the back of the cabinet. Without the computer, turn on the Digital Lynx. Verify that all power light indicators are all lit with a bright green LED. The boot light should be blinking on and off slowly. This indicates that the system is recognizing its specific configuration. Once the boot light is solid bright green, the system is ready. Check that the bottom 5 lights on all of the input boards are toggling on and off. The way in which they are toggling does not matter. This just indicates that the Digital Lynx SX is ready to be connected to the computer. Next, unpack the computer and place it in your desired location. Connect the mouse, the keyboard, and power. Refer to the HP computer setup for further instruction. It is best to connect all powered items to one power strip. This will reduce the chance for ground loops and will create one common ground for the system. Turn on the computer and log into Windows using the username administrator and password cheetah. These can be modified later if you desire. The system comes with 2 optical fibers of different lengths. Select the one that is most appropriate for your setup. Take the optical fiber and remove the dust caps off of both ends. Ensure not to bend the cable to a radius of less than 4.5 centimeters, as this can cause damage to the enclosed glass, which will cause transmission, degradation, or failure. Remove the dust cap off of the receiving port of the Digital Lynx and the PC. Once removed, the dust cap should stay in a bag or container for later use. Connect one end of the optical fiber to the Digital Lynx SX and the other to the computer. Both systems will have 2 optical fiber ports. Ensure to connect to port number 1 on both the computer and the Digital Lynx SX. On the computer desktop is a Run Cheetah shortcut icon to access Cheetah. With the Digital Lynx turned on and connected to the PC, click this icon. Ensure the Digital Lynx is up and running before starting up Cheetah. Always hardware first, software second. This will prompt a Cheetah welcome screen. There are 3 options to start Cheetah. For now, select the second button. Start Cheetah using the following file. This will start Cheetah using the default system configuration. See the Cheetah user manual for information on changing this configuration. Now, depending on your specific setup, you should see either a time window or a spike window. Start acquisition by pressing the Ctrl+A button. Check the acquisition status window and make sure that you have a timestamp running and ensure that no errors are populating this screen. Next, we will connect the head stage to the Digital Lynx SX, connect the tether adapter to the DRS panel, and then connect the tether and head stage assembly to the tether adapter. The system is now ready. Neuralynx fully sets up and tests all systems before shipments, but it is in good practice to test the system upon arrival and setup. The first system test that we will perform is a basic noise check. With the head stage and tether inserted into the DRS board, ensure the shorting plug is connected to the input of the head stage and the acquisition is running. On the Acquisition Entities and Properties page, highlight all of the channels and change the input to plus or minus 25 microvolts. Knowing that the system was completely tested at Lynx, verify that your screen looks similar to this. An input test board is used to test the input boards for signal pass-through and common mode rejection, or CMR. This confirms that analog inputs are converted to digital and transmitted to Cheetah as expected. Remove the input DRS module from the system. To test CMR, have the plus switch connected to the signal and the negative switch connected to the signal. Connect the input test boards to the minerator and to the input board. The test is typically performed with a signal that is less than 50 millivolts. You should see a very small signal when the input range is set to plus or minus 25 microvolts. To test signal pass-through, flip on the plus switch to signal while the other switch is in the down position to ground. This should produce an identical signal to the one you are transmitting. Now the input board has been tested. A signal mouse can be used for testing the entire system from the head stage to Cheetah. Reinsert the DRS input board module, noting that the alignment is correct with the input board labeling on the left and DRS on the right. Connect the head stage to the signal mouse through the appropriate connector. Pay special attention to the orientation of the connectors. The alignment pins will prevent backwards connections, and the black part number should be on both sides of the connectors. Connect the minerator to the signal BNC output. The signal mouse uses a 1000 to 1 reduction to test the input signal. It is an easy way to check for signal pass-through and reference capabilities with a signal in close range to neural activity amplitudes. S1 through S5 controls the 1000 to 1 reduced signal to various sets of signals on the head stage connector. For example, for a head stage 36, S1 controls channels 1 through 8, S2 controls 9 through 16, S3 controls reference 1 through reference 4, S4 controls 17 through 24, and S5 controls 25 through 32. See the Signal Mouse user manual for head stage specific channel assignments. Set the signal switches to up position and the reference switch to down position. The standard test involves configuring the minerator to output a 1 volt square wave at 20 Hz, so Cheetah will display a 1 millivolt square wave at 20 Hz. If the reference switch is set to the up position, all channels should flatline. The system is now tested and all ready to go. Please contact us if you have any questions or for more information.